What we're going to look at right now is a concept called completing the square. And completing the square, has, what square are we completing? What does that square mean? And lots of different people, lots of different instructors talk about lots of different ideas. And here's just one of the many ways you can think about that. Let's say, for example, that we had an x plus a 4 times an x plus a 4. Well, that's an object times another object. And what I'm going to do is I'm going to put that into a little bit of a graphical or a visual representation where I have an x plus a 4. I'm going to multiply it by an x plus a 4. Almost like I was trying to take the area of a square. So let's look at each of these squares individually and see where they're coming from. So I have an x, the length of this side times the length of this side, x times an x, gives me an x squared. Over here I have a length of 4 and the length of an x, x times a 4, of a 4x. Down here, length of a 4, length of an x, the size or the area of this box is also a 4x. And then the last one, I have a length of a 4 and the length of a 4, 4 times 4 equals 16. And so if I'm trying to find all the area inside that box, I can add them up. I have an x squared plus a 4x plus a 4x plus a 16, or x squared plus 8x plus 16. And there I have a perfect square trinomial. Well, no surprise, that's what you would have gotten exactly when you factored this. First times first, x squared. FO outers, x times a 4, 4x, inners, 4x, and outers is 16. So I have x squared plus 8x plus 16. Exact same thing. Well, okay, so how does that help us here? Well, let's say that we are working our way backwards, and we're only given part of this number. For example, we're given x squared plus 8x, but the 16 is gone. In fact, we don't ever remember it was a 16. So how do we figure out what that number is? And so the little bit of the process is how a lot of people call it completing the square. So I'm going to start with an x squared plus an 8x. I want to complete that number with a very particular number, a magic number, so that it forms a perfect square trinomial. And well, we already know it's a 16, but let's pretend we forgot that. So how do we find out what that number is? Well, I'll take this middle term, that 8, divide it by 2 and square it. Divide it by 2 and square it. 8 divided by 2 is a 4. And 4 squared with my toes is a 16. So that's the magic number that makes this a perfect square trinomial. And that's important because I might want to factor this down to x plus 4 squared, or x plus 4 times x plus 4. So what we're going to do is we're going to practice a couple of ways of how do we take a start of a trinomial, complete the square so that it turns into a perfect square trinomial. We'll know why in a couple more example problems of why we want to do this. Right now we want to kind of have an understanding of how do we do that. So let me give you another example. X squared minus 7x. What's the magic number that's going to complete the square? Well, we do the exact same thing. Look at that middle term. The middle term is a negative 7. So I'm going to take that negative 7, divide it by 2, and square it. So negative 7 divided by 2 is negative 7 halves. And negative 7 halves squared is a positive 49 fourths. So that's the magic number that makes it a perfect square trinomial. And then I can factor that down. That factors down to x minus 7 halves squared. And that's my perfect square. That's what I'm wanting to get to. One last example of how to find a magic number so that you complete the square. X squared plus 3/5 x. All right, what's at the end of that number? What number do I put down there? Do I make one on up? I hope it works out. Well, let's just do the exact same thing. Let's take this middle number, divide it by 2. Oh gosh, 3/5 divided by 2. I don't know how to do that. I'm going to have to go back a few chapters here and figure out what's going on. 3/5 divided by 2 equals 3/10. 3/5 divided by 2 equals 3/10. And if you don't remember that, please back up and review this. It's important because it's going to happen over and over and over again. So then 3/10 and 3/10 squared equals 9/100. So there's the magic number. X squared plus 3/5 x. If I want to complete the square of this trinomial, I need to add a plus 9/100 to it. And that's the only number that turns this guy into a perfect square trinomial. And so I'd factor down to x plus 3/10 squared. That's what I want to see. And we're going to start to look at, well, big deal, Willie. Why does it matter? Well, it will matter, and we're going to watch that very shortly.